Okay, so hello everyone. Today I'm going to show you guys on how to make postfix notation 0, 1, 2 and 3 address instruction. For our equation today is x equals a plus b times c minus d divided by e plus f minus g. So, firstly I'm going to show you guys on how to make the postfix notation. So I'm just going to write it down first. Okay, so firstly, you need to know that postfix notation, the operator must be behind the operands. So operands are A, B, C, and the operators are like plus, minus, and those stuffs. Okay, so I'm gonna show you guys on how to make postfix notation. So basically, firstly, I'm just gonna show you first. A, B, C times plus. So basically BC is times B times C, which is this, and A will plus with this BC. This A will plus with this BC. So okay, so we see that the operators are behind the operands. So moving on to D and E. So D, E, divide, and minus. So DE divide is this one. This minus is basically this whole thing minus with this D divided by E. So for the next one, F minus G, which is F, G, minus, and plus. So why do we need to plus? Because there's a plus sign here. And why do we need to minus? Because F minus G, yeah. And we put the operator behind it. So this is how you make the postfix notation. Okay, moving on to zero address instruction. Okay, so zero address instruction is so easy. So you just need to copy down this whole thing. It's not copy down, you must use some words. Yeah, okay, so I'm going to show you guys. So basically it's push A, then push B, push C, mul, add, push D. I'm going to explain to you guys later. So push A, divide, sub, push F, push G, okay, and sub, add, and pop X. So from here, so push A. So this zero address instruction consists of like push, mul, add, div, sub, and pop S. All these variables you need to memorize. So you just follow these things, and just if it's like a character, just push, and for like this operators, just write the operator name, which is like multiply, just put mul, and for addition it's add, for division it's div, for subtraction it's sub. So then at the end you must pop X. So that's all for zero address instruction. So now I'm going to start with one address instruction. So one address instruction it's not that hard, but it's easy actually. So we're going to start it from behind, which is F. So that's like in one address instruction we have mnemonics, which are abbreviations to represent operators such as add, sub, and mul, division, store, and load. So firstly you need to load the data. So load F. So we need to sub it with G. So we just write sub G. And then we need to store it in a memory, in a storage. So we just store it in any variable. If you want to just store it in one variable, for example R1. Okay, so this thing is R1, so remember that. So we're gonna load this one. So we're gonna load D, and then div E, and then we're just gonna add it with this one. So just now we store it at R1, so we just add it with R1. Okay, so we just store at R1. So for now we need to settle this front one. Okay, so we need to load it first. So we need to load B mal C, and we just add up with A. Okay, so add A. Then we can just sub with this whole thing. This whole thing is R1 because we store it at R1. So we just sub with R1, and we need to store it at X, because X is where we need to store it. Okay, I think that's all for one address instruction. So we finished one address instruction, so we're going to go ahead with two address instruction. So for two address instruction, there's already a storage where you can store the value. So from this equation, so basically we start from here. So like normal, just load R1 B. So R1 is the storage, so we load B and we store it at R1. Okay, so next we're gonna mul it. We're gonna multiply it. So mul R1 C. So from here, where B is gonna times with C, and it's gonna store at R1. So okay, so we're gonna just add it with A. So at R1 A. So basically R1 has all of this. R1 is this whole thing is stored in R1. So we're gonna load a new one. We're gonna start with D. So we're gonna store it in a different storage, which is R2. So we're gonna load D first. Then we're gonna divide by E. So div R2 E. So it is still stored in R2. So this is R2. So we're gonna have 3 storage. For the third storage, we're gonna put this. So we're gonna just load again. Load R3 with F, and just sub G. Sub R3 with G. So this thing is R3, this is R2, and this whole thing is R1. So now we're gonna find X. So we're gonna load this R1 into X. So X R1. So we're gonna sub this thing. So now R1 is in X. So basically this thing is X. So sub X with R2. So this thing minus D divided by E, which is R2, and we store it at X. So basically this whole thing is X. So now we're gonna plus with R3. So at x r3. So this is x, so we plus it with r3 and we store it at x. So all of this is x because our storage is x. So that is all for to address instruction. So now we're going to do the tree address instruction. It's more simplified and it's easier actually. So it's not like 1 and 2 address where you have to store and load. You can just load and store in just one line. So okay, so we're just gonna start with B and C. Okay, so model, so storage, which is like R1 for instance. So BC, so B times C R1. So R1, this is R1, it's stored in R1. So we need to add up with A, so we just add R1 and A. So R1 just now was this, so we had plus it, we plussed it, and now we store it at R1. So this whole thing is R1. So moving on to D and E. So D and E we need to divide. So div, we put it in a new storage, R2 for example. So R2 D E. So D divided by E and stored in R2. So this is R2. So for F and G we're going to store it in a new storage, maybe R3. Okay, so we're gonna sub F sub R3, which is the storage, F and G. So F minus G and into R3. So this is R3, this is R2, and this is R1. So now we're going to load this R1 and minus it with R2 and plus it with F minus, which is F minus G, which is R3. So firstly we need to load D first. Load R1. Sorry. So we need to minus, which is sub X R1 and R2. So basically this is R1 and this is R2. So R1 minus R2 and we sub it in X because it's what the question wants. So R1 minus R2 and start in X. So this whole thing is X. Okay, moving on, we're going to add with this one. So it's going to be add X, X and R3. So from here, this whole thing is X. So this thing is R3. So we add these two equation and store it in X. So the whole equation now is X as we store it in X. With that, that is all for tree address instruction. So just now we've learned about zero address instruction. Okay, this is zero address instruction for the equation that we've learned just now. Okay, so on how to make a stack diagram. So firstly you need to for the first diagram you need to just push A, and for the second one you need to push B, the third one you need to push C. So for multiply, you just multiply B with C, so B times C, and for the next one is add. So you add all of this, you add A with B times C, so A plus B times C. So for the next one we're just gonna push D, so we just copy this, so we just push D and then we paste again and just push E. for this one, divide. So this means D is divided by E. So D is divided by E. So for the next one is sub. So basically this one sub with this one. So the equation will be, the next stack diagram will be minus D E. So for the next one, you just need to push F. So you copy this, put it in the first lane, then you just push F. For the next one, just push G. So just copy back the same thing. So G. Then you need to sub. This sub means F minus G. So F minus G. Yeah, I just paste it again. And the last one is add. So add this equation, add with this F minus G. So the last one will be the same, and you just add up plus and F minus G. And this is your stack diagram. That's all from me. Thank you.